So we're going to be talking about graphs. And before we talk about some graphs, there's some vocabulary to talk about. And if you remember from Math 2, one of the very first things in Math 2 that you did was transformations. And you moved functions around, and you moved them to the right and the left, and you moved them up and down, and you reflected them, and did all those kinds of things. So the first vocabulary word here, it says blank changes a graph's size, shape, position, or orientation. It's a transformation. So when you make a transformation with a graph, you can change all kinds of different things. We can make it bigger or smaller, we can just move it over, or flip it, or do all kinds of other things. So the next thing are the three different kinds of transformations that's important. So the first one says a transformation that shifts the graph horizontally or vertically but does not change the size, shape, or orientation. So if you have a graph and you go up or down with it, or right or left, that's called a translation. Because you're just moving it over. You're not really changing anything about it because you're just moving it. Okay, the next one says that it's when a graph is flipped over a line. And it talks about we can flip it vertically and we can also flip it horizontally. This is called a reflection. So a reflection is like when you have a graph and then you flip it over something, depending on whatever it is you want to flip it over. Next one says that we want to change the size of the graph. So you have a graph and you want to make it bigger or you want to make it smaller. And stretching is making it bigger, compressing is making it smaller. But it depends on the graph, and I'll explain that in a little bit. It happens when you multiply the function by a number. This is called a dilation. Now, there was one other kind that we talked about in Math 2, and it was called a rotation. That's where you like turn it around. We're not really going to be doing anything with rotations in Math 3, but those are the kinds that we'll be looking at. We'll be looking at translations, reflections, and dilations. So we're going to take a graph and we're going to do those things with it. Now, before we talk about the graph of an absolute value, let's talk about what absolute value actually is. Okay? An absolute value changes negative numbers to positive. If you take the absolute value of something and it's a negative number, it changes it to a positive number. Because the absolute value is really just the distance from 0 that a number is. And since it's a distance, it's always positive. Okay? So for example, if I want the absolute value of 2, 2 is already positive, so it just stays positive, and you get 2. If I want the absolute value of negative 2, I'm going to change it because I want the distance from 0 that negative 2 is, and you get 2. Okay? And then the last one, I want the negative absolute value of 2. So what you do there, the absolute value of 2 is just 2. And then the negative's on the outside of it, so you just put a negative on the outside of it. That's not really part of the lesson, but I just wanted to talk about it so that you understood what absolute value was before we started doing a bunch of stuff with absolute value. Alright, the graph is the important part for today. And let's talk about the graph of the absolute value. So I'm going to move this over just a little bit, and I'm going to show you on Desmos, if you want to graph something, you can always put y equals. It doesn't hurt anything. Y equals, I know on the regular calculator you can't do that, but you can do it here. Down here is where all of our functions are. You'll notice there's an absolute value of a right there. So we're going to click that. The absolute value sign will come up. Then we're going to use this x and y. There is a keyboard, but you can just use the x and y here. So press x. And so there's what the absolute value of x looks like. It's a V. And it's centered right there at 0, 0. That's the important part. It's really, really important that you know what that graph looks like, because what we're going to be doing is we're going to be moving that graph around. We're going to take that graph and move it to the right and the left and the up and the down and flip it and all that kinds of things. Okay? So this is called the parent function because the parent function is the function that you start with. Okay? And you can always graph it. When I say to you, what happened to this graph, you can always graph this original graph and then graph the new one and just compare it. Okay? And I'll show you that in just a second. All right. So we're going to be looking at some graphs and talking about their transformations. But before we do that, let's just look at the general form of it. This is the general form. Okay? The A stretches and compresses. Okay? If the A is a regular number, like 2, 3, 4, it's going to stretch the graph. And I don't know why I wrote H. I meant A. There we go. If A is like a fraction, it's going to compress it. I'm going to show you an example of that real quick. If I put 2 absolute value of x, look at the graph a second. So the red one is the original. The blue one is stretched. So I take that red one and I stretch it up. It looks like it got smaller because it got skinnier, but it was stretched because it took the red and it stretched it up. Stretch is like the real technical word. If you wrote got skinnier, I'm going to count get skinnier. Okay, because that's what happened. It got skinnier. Alright, but stretch is the technical word. Instead of 2, if I put a 1/2, it got wider. So if you tell me it gets wider, that's okay. The technical word is that it compressed, because if you take that red one and you squeeze it together, it makes it really, really wide. Okay, does that sort of make sense? Alright, so that's what A does. I think that's the hardest one to think about as far as the words. H moves the function right and left. If H is negative, it moves it to the right. If H is positive, it moves it to the left. And that's opposite of what you think should happen. Because you think negative should be left and positive should be right. But that's not exactly what happens. So let me show you what I mean. If I put absolute value in here, oops, let's get rid of all that. Absolute value, and I put x minus 2. Negative 2, oh, that means I should move it to the right, because that's what I said here. But let's see if that happened. Here's the red one. Start always like at the bottom of it. If you click on it, you can just click on the bottom of it. And figure out where the bottom went. Well, it went over 2. It went right 2. So that's how we can look at that. Okay. If I changed it to plus 3, notice it went to the left 3. Okay? Alright, the K. If this stretches and compresses, and this moves it right and left, the K is going to move it up and down. So if K is positive, it moves up. K is negative, it moves down. If it's helpful for you to memorize those things, you're welcome to do it. You can always graph it though. Like in Math 3, the Desmos, you can always use it. Even on the EOC, you get the calculator the whole time. So there's never a time I'm going to say you can't do this with a calculator. You can use the calculator the whole time. So if you would prefer to just graph it and look at it and then compare it, that's fine. That's just the rules in case you don't want to graph it. Okay? So let's look at the first one. The question says for us to describe the transformations. So I'm going to keep that y equals absolute value of x in there. And then I'm going to graph what I want to figure out. Because I want to compare the new one to this one. Okay? So I'm going to just plug it in there. 3 absolute value x plus 2 minus 3. So the green one's what I'm looking at. Okay? The first thing I do normally when I'm looking at them is I start, like on the red, I start at the 0 and I count left or right and up and down. Okay? So to get to the same place here, I'm going left 2, and down 3. Basically, I start at the vertex of that one and the vertex of that one, and I just compare. So right there is giving me some of the information. It went left 2, and it went down 3. And that makes sense, because that's left 2, down 3. There's 3 numbers here, so there's 3 things that have to happen. So I've listed 2 things. There's one other thing that happened. It's got skinnier. And if you write skinnier, that's okay. Skinnier also means stretch, and so we're just going to write stretch. You can write stretch by 3 if you want to, or you can just write stretch. So number 2, all that happened is it went to the right 1, and then it went up 2. And notice there wasn't a stretch or a compression because there's no number up in the front. And it's just the same size that it was originally. So this one went left 3, it went down 1, and this one did have a stretch. And looking at the graph, it got skinnier, and that's called a stretch. Okay. Let's look at number 4 together. And I think you maybe could have done it, but there was an interesting thing about this one that I wanted to show you. So let's go ahead and graph that one, -1/3. Notice when you do fractions, you just press the divide sign, but press the over arrow button to get back the side of it. Okay, the over arrow just moves it so that it doesn't stay on the bottom. Then you do absolute value x minus 2. Move your arrow over to get outside of the absolute value, and then +1. So that graph looks really strange. Okay? Instead of going up, it went down this way. So that's a reflection. And what made that happen was this negative in the front. Okay? That negative made it flip over. So we're going to say that there's a reflection or a flip. Another thing that happened, it got really wide. And so you can say wide. That also means that there was a compression. And then I still can look at the vertex. It's hard to tell where the vertex is here, but let's go ahead and, there we go. There's a bunch of things. Anyway, there's the vertex, and here's the vertex here, so it looks like it went right 2 and up 1. And the reason I wanted to show you that one and you see that one is so that you knew what that negative on the outside did. Okay? Alright, the other thing that we need to talk about real quickly about absolute value functions, or really any kind of function, is about domain and range. Okay? Domain and range represents what functions or what values that the function can take. Alright? The domain represents the x values of the function, and the range represents the y values of the function. When you do domain and range, you're thinking about how far left does it go and how far right does it go for the domain. And for the range, you're thinking about how far up does it go and how far down does it go. Okay? And so there's a couple things I want to show you real quick before we actually talk about the domain and range. And that's just some notation. If you see all real numbers, you can write the words all real numbers. You can also write negative infinity to infinity. You could also write this little fancy R thing that has like 2 lines there on the side of R. All 3 of those represent all real numbers. All real numbers mean that everything is included in the domain. Okay? And so you would include just everything, the way that that's listed there. Alright, some other things that I just want to show you. This is called set notation, and you may have seen that in math too, but I just want to show you the interval notation just so that you're not surprised. When it says x is greater than 2, it means that you start at 2 and you go to infinity. That's just another way to write that. Y is less than 5 means that you want to start at 5, but then you want to go to everything before 5, and so there would be a negative infinity there. x is less than or equal to 3 means that it's kind of like this one, how there's a 3 and it's everything before it. The only difference is because they have an equals right here, you put a bracket on the 3. A bracket means that it includes that number. And a parentheses mean that it doesn't. You never put a bracket on infinity and negative infinity because you never really get there. But you do put brackets on the numbers. Alright, this one is kind of like the first one, how it starts at -1 and goes to infinity. But because there's an equals right there with the greater, we put a bracket on it. So the answers that you're going to see here in just a second for the domain and range are going to have like brackets and parentheses like that. Okay? So here's what we're going to do to find the domain and range. We're going to first graph it. And I'm going to take off the absolute value of x because I'm not asked, like, which way does it go. So let's put it in here. X minus 2 plus 3. Alright. I'm going to graph it here just so we can talk about it. You don't have to graph it unless you want to. It's up to you. It looks kind of like that. Alright. To figure out domain and range, one thing that might be helpful is for you to put negative infinity and infinity on the x-axis, and then put negative infinity and infinity on the y-axis. If that's not helpful for you, then that's okay. You can do it without that, but this is one way that might help you understand how to write domain and range. Alright, domain has to do with moving left to right. And as far as this graph is concerned, it starts over here on the left and it keeps going to the right forever. It never really stops. It just always goes left to right. So what that means for the domain is that it goes from negative infinity to infinity. There's nothing weird about it. It never stops. For the range, it does go up forever. So infinity will be on part of our answer. However, it doesn't go all the way down to here. It stops right here. That's like our starting point or whatever. So when you come over here to the graph, click on it, and think about where that would be on the y, where does that graph stop? At 2. So when we write the range, we're going to write 2 to infinity. And we put a bracket on the 2 because it includes that number. So left to right is domain. Up and down is range. And when I think about where it stops, I think about where it stops right here. Notice it's stopping at -2. That's where it is on the y-axis, so this will be a -2. So my range is going to be -2 to infinity. You always start like down and then go up. Now, the only thing that's different about domain and range is if instead of the graph going up like this, if the graph goes down like this. Okay, so let's look at one that's going down. Number 7 is one that goes down. So negative, absolute value, x. I'm arrowing over to get on the outside there. There's the graph. Alright. Let's graph what it would look like. Like I said, domain is easy because the domain is always going to be all real numbers or negative infinity to infinity. The range is the one that's kind of tricky. And I'm thinking about the y-axis. This is negative infinity, there's infinity. See, the graph's going down, so I know I'm going to have to include negative infinity, and I've got to go all the way to wherever the top of it is. When I look at the graph, the top of it's at -3. So it's going to be negative infinity to -3. look at one more and we'll be done with notes. Alright, let's go ahead and graph it. Negative 3, absolute value, x plus 2. Oh, goodness. That's doing. There we go. So there's that graph. Looks kind of like that. Again, I told you domain's pretty simple. The range is the one we've got to figure out. I know it's negative infinity up to wherever this is. That's on the x-axis, so that's 0. So that means the range is going to be negative infinity to 0.